Welcome to the tutorial looking at more right triangle trigonometry ratios. Now, just as a refresher, we know that the right triangle has a hypotenuse. And if we look at angle A, it has an opposite to angle A, and it has a side that is adjacent to angle A. So what does that mean when we look at other trigonometry ratios? We've already looked at TOA from SOHCAHTOA, so we have TOA here. And TOA, if you recall, is the tangent ratio. So the tangent of A is opposite over adjacent. And we know that already from previous videos. There are two more. There's SO and then there's CA. So if I look at the acronym TOA, I know that the T stands for tangent, the O is opposite, and the A is adjacent. So what do you think SOH and CAH equal? The S equals the sine. This is the sine ratio. And then the O, the same as in TOA, is the side length. Opposite angle A. And the H is the hypotenuse. So the sine ratio is the side length opposite of the angle divided by the hypotenuse. Or as we like to say, the sine of A equals opposite over hypotenuse. So what does that mean for CA? The C stands for cosine ratio, and it equals the side length adjacent to angle A divided by hypotenuse. Or as we like to write it, cos A equals adjacent over hypotenuse. Now I can write these in terms of A, B's, and C's. So I'm going to do that just so you can see what it looks like, how you might see it on questions in tests, quizzes, or even in your homework. So sine A equals the opposite, well that is CB, all over the hypotenuse, which is CA. That's the line names. That means that cos A equals BA, which is the adjacent line, divided by CA, the hypotenuse line. And of course, tan of A equals CB over BA. And that's how sometimes you will see it written for all three of these in your homework, quizzes, or on tests. Let's look at a real example here with some numbers. So we have triangle BCD. And BCD has side lengths. BC is 12, CD is 5 centimeters, and the hypotenuse is, or BD, is 13 centimeters. So what if I asked you to determine sine D and cos D? And I want you to look at them to the nearest hundredth. So we're going to follow our formula. So I know that sine D equals opposite over hypotenuse. So that's going to be the line of BC divided by my hypotenuse BD. And that equals 12 divided by 13. If you recall from our other videos, what do we have to do to solve for D? So in order to find angle D, I have to take the inverse of sine with my opposite over my hypotenuse lengths. So this is what you're actually going to put in to your calculator. So you're going to put in second sine. So you have to put second and then the sine, because you need to get the sine 1, -1 symbol. And then of course you're going to put 12 over 13. That's for your calculator. And the answer to that, of course, is 67.38 degrees roughly, because again, I'm rounding to the nearest hundredth as per the question asked. Now let's look at cos D. So I'm looking at adjacent divided by hypotenuse. So that is CD divided by BD. And I know that CD is 5 centimeters and BD is 13. And that equals cos D. Now again, I need to isolate out to solve for D, angle D. So in your calculator, it's going to be cos inverse 5 divided by 13. And you should get angle D as equaling approximately, because again, we're rounding to the nearest hundredth, 67.38 degrees. Well, hold up a second. Sine D equals cosine D. Should that be the case, where my adjacent divided by hypotenuse is the same as my opposite divided by hypotenuse? The answer is yes, because we're looking at angle D. The sides don't change, the side lengths don't change the angle. So if it was a similar triangle, but say different lengths, and my angle was 67.38 degrees, it'll stay 67.38 degrees. So if you had a different answer for cos D than you did for sine D, you've made an error, and you really need to take a check on that. Let's give you an example that you can try. And what I want you to try is this one here. I'm going to take out my 55 and my 6.8, and I'm going to give you 8, 15, and 17. And I want you to find the angle for G. So you're going to find cos, FG. I put an H by accident. And then what I'd like you to do is find the sine for G. So we're finding our angles for this angle here of G. So what is that going to be? Pause the video, put your numbers into the formulas that we've gone through in this video, and come up with the answers. Welcome back. So of course, to find cosine of g, we're looking at adjacent over hypotenuse, so 15 over 17. And to find angle g, you have to put in your inverse, 15 over 17. So if you put that in, you're going to get an answer of 28.07 degrees. Now, for sine g, again, it is opposite over hypotenuse, so 8 over 17. So my angle G, again, using your calculator for the inverse, of 8 divided by 17 gives me angle G equaling 28.07 degrees. So you should have gotten the same again.